Hello everyone. In this video, I am going to discuss about the code called Casino, which is useful to model the photovoltaic system and basically what happens when the sunlight is incident on the solar panel or solar cells. Okay, for that. Let's first find out. This is the find out where you can download the code. This is a website. I will put that website in the description down the video, and you can get from there if you are interested. You can download from here. There are two versions available, V3 and V2, and they have all the information. That are very nice tutorial, and everything is there. So now I have downloaded this version V251, which is basically here. And once you download and unzip it, you're gonna to see the executable here. You just click on that. You will end up opening that window. Now let's okay. So now let's now build a solar cell. For that, let's go paper, which is on RSC Advances. This is the paper where where they have designed solar cell with the silicon carbide, p-type silicon carbide, intrinsic silicon carbide, n-type silicon carbide, and substrate. Now let's build that. For that, you just go to the file, go to the new, and now you see that window. Now go to the add layer. First one was p-type silicon carbide, which basically is silicon carbide. I assume doping boron will be the p-type, but again, this is a demonstration purpose, demo purpose, so you can use the exact what it's supposed to be from the experimental say demonstration or experiment scenarios. Done. Now let's add another layer, which is the intrinsic. I would call ISIC, so which is just silicon and carbon. Again, let it define its density. You don't have to use. If you know exact numbers, then you can use these to uncheck them, check them, and use the number what you know. Okay. Now then layer the N type SiC, which is again silicon carbon, and I assume nitrogen doping would give you N type. Then another layer, which is substrate. You can use anything substrate, but here I'm using aluminum. Okay, done. Now let's define the thickness. Let's suppose this say 25 nanometer. 25 nanometer, it's a variable. Let's say 25 is fine for now. Then 25, let's say this is 50 or 100, even 500 does not matter. Okay, so next, now here you define your energy of the solar cell. Let's say 5 kilo electron volt or so. Again you have to get that number from the experiment, right? So number of electron to be simulated, normally you should be simulating 200,000, but for the demo purpose we can use 20,000. And the beam radius is 10. You can play with this if you know exact number. And then next, this is the distribution window, where these all these options are well defined and well known, but you can change these numbers if you know exactly. Otherwise don't change these numbers. Next, so number of trajectories I defined to 2000. Basically you can go up to not up to, but 100,000 is a good number. Next, this is the physical model where physics involved. So total cross section, which is given by this one, ionization potential given by this one, so partial cross section by this one, random number generator by that one, and so on. If you know exactly which model you want to use, you can now change this model as well. Okay, this is finished. Now our input setup is finished. So if you say yes, it will run calculation. If you say no, you still have option to opportunity to run calculation through the simulation. I would say yes. Okay, let's wait for a while. and this is already in 6%. Okay, this is what is happening, guys. Sunlight is incidenting on the p junction, which is the p junction. That's intrinsic layer. That's the n layer. It looks like calculations are done. So let's say go there. One set of calculations are done. Okay, so let's go to distribution. So now you see the output files like so you see that this sound, because there are a lot of calculation need to be done, but I'm showing you one. uh, so Z max is the maximum backscattering. That's again the backscattering is a function of the depth. The backscattering energy, so 0 to 5, and that's how it look like. Transmitted energy, it also plot transmitted energy plus surface radius of the backscattering, so energy surface of the BE, again backscatter angle, backscatter angle energy, energy by position. So this is what very important is. So the P layer, light incident here, okay, the intrinsic layer and the N layer and the substrate layer. Now you see, now look at the legend here, the percentage. This one is 5%, the red one is 10%, and so on. The purple one is 90%, which basically 90% of the light is inside the p junction, which basically means the most of the electron hole pairs generated are of somewhere here. Okay, then recombination takes place and so on. But now you can play with the thickness such that this energy should not go to the substrate, should not even go to the n junction. This energy should stay up to the intrinsic layer. That's how you define the solar cell. Okay, then now it also obtained X-ray for all the elements, use element. Okay, it also define, it also compute the sorry, it also compute the X-ray radial distribution function for all the element, this element. So not observed in observed, so means the energy of the sunlight is observed or non-observed. Similarly, boron, carbon, nitrogen, silicon, all these involved, and the same thing will be similar kind of output for all these 6 to 10 kilo electron volt. But basically this is how you analyze the data. So guys, thank you very much. Please leave a comment and let me know if you need more information about casino or about photovoltaics, how to design, how to define different kind of layers, where current, how to measure current voltage, how to see electron hole pair generation, recombination, how band structure changes with the depth, or with the power of the solar cell and the power of the sunlight and so on. If you like the content, please subscribe.